Module 1, Introduction to Artificial Intelligence. Point 1, what is artificial intelligence? Definition of AI. Artificial intelligence is the field of computer science that focuses on creating machines capable of performing tasks that typically require human intelligence, such as visual perception, speech recognition, decision-making, and language translation. Goals and objectives of AI research. The primary goal of AI research is to develop systems that can learn, reason, and act autonomously in complex environments. This involves creating algorithms and models that can process and analyze vast amounts of data, identify patterns, and make decisions based on that information. Real-world examples of AI applications. AI is already being used in various industries, such as healthcare, e.g. medical diagnosis and drug discovery, finance, e.g. fraud detection and algorithmic trading, transportation, e.g. self-driving cars and route optimization, and entertainment, e.g. personalized recommendations and virtual assistants like Siri or Alexa. 1.2 History of Artificial Intelligence. Early developments, 1950s, 1970s. Turing test. In 1950, Alan Turing proposed a test to determine whether a machine could exhibit intelligent behavior indistinguishable from that of a human. This laid the foundation for evaluating AI systems. Dartmouth Conference. In 1956, a group of scientists, including John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon, held a conference at Dartmouth College to discuss artificial intelligence. This event marked the birth of AI as a formal research field. Early AI programs. Some of the earliest AI programs included the Logic Theorist, 1956, which could prove mathematical theorems, and the General Problem Solver, 1957, which aimed to solve a wide range of problems using heuristics. AI Winters and Resurgence, 1980s, 2000s. Expert systems. In the 1980s, expert systems gained popularity. These AI systems aimed to emulate the decision-making abilities of human experts in specific domains, such as medical diagnosis or equipment repair. Neural networks and machine learning. The late 1980s and 1990s saw a resurgence of interest in neural networks and machine learning. These approaches focused on creating AI systems that could learn from data and improve their performance over time. The role of computing power and big data. The growth of computing power and the availability of large data sets played a crucial role in the advancement of AI during this period. More powerful computers and access to big data enabled researchers to train more sophisticated AI models. Recent advancements, 2010s present. Deep learning. Deep learning, a subfield of machine learning that uses artificial neural networks with multiple layers, has led to significant breakthroughs in areas such as image and speech recognition, natural language processing, and robotics. Reinforcement learning. Reinforcement learning is a type of machine learning where AI agents learn to make decisions by interacting with an environment and receiving rewards or punishments for their actions. This approach has been successfully applied in games like Go and chess, as well as in robotics and autonomous systems. Generative models. Recent years have seen the development of powerful generative models such as GPT-3, Generative Pre-trained Transformer 3, for natural language generation and DALL-E for image generation. These models can create highly realistic and coherent outputs based on the patterns they learn from vast amounts of data. 3 Types of AI systems. Narrow AI, weak AI, definition and characteristics. Narrow AI, also known as weak AI, refers to AI systems designed to perform specific tasks or solve particular problems. These systems are focused on a single domain and cannot generalize their knowledge to other areas. Examples. Some examples of narrow AI include image recognition systems that can identify objects in pictures, speech recognition systems that can transcribe spoken words into text, and chatbots that can engage in limited conversations with users. General AI, strong AI, definition and characteristics. General AI, also known as strong AI, refers to AI systems that can perform any intellectual task that a human can. These systems would have human-like cognitive abilities, such as reasoning, learning, and problem-solving, and could apply their knowledge across multiple domains. Challenges and current status of research. Developing general AI is one of the ultimate goals of AI research, but it remains a significant challenge. Current AI systems are still primarily narrow, and creating AI with human-like intelligence requires advances in areas such as common-sense reasoning, transfer learning, and unsupervised learning. Researchers are working on various approaches to achieve general AI, but it is still an ongoing area of research. Superintelligence. Definition and potential implications. Superintelligence refers to an AI system that surpasses human intelligence in virtually all domains. Such a system could have profound implications for humanity, potentially leading to rapid technological advancement or, if not properly aligned with human values, existential risks. Theoretical considerations and long-term goals. The development of superintelligent AI is a long-term goal that raises significant theoretical and ethical questions. Researchers are exploring various paths to superintelligence, such as recursive self-improvement and brain-computer interfaces, while also considering the potential risks and the need for robust safety measures. 1.4 Ethical considerations in AI research. Bias and fairness in AI systems. Sources of bias. AI systems can inherit biases from the data they are trained on, the algorithms they use, or the humans involved in their development. For example, if an AI system is trained on data that reflects historical discrimination, it may learn to perpetuate those biases in its outputs. Consequences of biased AI. Biased AI systems can lead to unfair and discriminatory outcomes, such as perpetuating stereotypes or denying opportunities to certain groups of people. This can have serious consequences in areas like hiring, lending, and criminal justice. Techniques for mitigating bias. Researchers are developing techniques to mitigate bias in AI systems, such as using diverse and representative training data, applying fairness constraints to algorithms, and regularly auditing AI systems for potential biases. Transparency and explainability. The importance of understanding AI decision-making processes. As AI systems become more prevalent in decision-making roles, it is crucial to understand how they arrive at their outputs. Transparency and explainability are essential for building trust in AI systems and ensuring they are used responsibly. Challenges in achieving transparency. Many AI systems, particularly those based on deep learning, are often considered black boxes due to the complexity of their decision-making processes. This can make it difficult to interpret and explain their outputs. Approaches to explainable AI, XAI. Researchers are working on developing explainable AI, XAI techniques, such as feature importance analysis, rule extraction, and counterfactual explanations to make AI systems more transparent and interpretable. Privacy and security. Protecting personal data used in AI training and inference. AI systems often rely on large amounts of personal data for training and operation. Ensuring the privacy and security of this data is crucial to prevent misuse and protect individuals' rights. Securing AI systems against malicious attacks. As AI systems become more integrated into critical infrastructure and decision-making processes, it is essential to secure them against malicious attacks, such as data poisoning, model stealing, or adversarial examples. Balancing privacy and utility in AI applications. There is often a trade-off between preserving privacy and maximizing the utility of AI systems. Researchers and policymakers must work together to find appropriate balances that protect individual rights while enabling the benefits of AI technology. Societal impact and responsibility. Potential effects of AI on employment, education, and social interactions. AI has the potential to disrupt many aspects of society, from the job market to education and social relationships. It is important to consider and address these impacts proactively to ensure a smooth and equitable transition. Ethical guidelines and principles for AI development and deployment. Various organizations such as the IEEE, the European Commission, and the OECD have developed ethical guidelines and principles for the responsible development and deployment of AI systems. These guidelines emphasize values such as transparency, fairness, accountability, and privacy. The role of researchers, policymakers, and society in shaping the future of AI. Shaping the future of AI requires a collaborative effort from researchers, policymakers, and society as a whole. Researchers must prioritize ethical considerations in their work, policymakers must create appropriate regulations and governance structures, and society must engage in informed discussions about the implications and desired outcomes of AI technology. This comprehensive overview of the Introduction to Artificial Intelligence module covers the definition and goals of AI, its historical development, the types of AI systems, and the critical ethical considerations surrounding AI research and deployment. By providing a solid foundation in these topics, This module prepares learners to delve deeper into the technical and philosophical aspects of artificial intelligence in subsequent modules.